Okay, let's continue to talk about UART. Okay, let's go through the test code we went through before. So this is a brief block diagram of UART, right? So you have very important component called TX54. This is actually buffer, right? In Zinc device, right? This is your port, right? Z port, and that is a Zinc. This one is a Zinc device, Zinc 7000, right? That device. Then you have UART, IO device, and CPU. CPU is accessing this UART through that connection. That connection is called XC, Advanced Extensible Interconnect. I think that is that company's ARM's proprietary protocol. So if you join, probably after graduation, if you join Samsung Electronics or LG or SK Hynix, then if you are involved in SoC, system on chip development, hardware development, there is a system on chip. Whole system is inside one chip, right? CPU, small memory, and IO devices. Whole system is inside one chip. That is called system on chip, SoC. So if you are involved in SoC development, then probably you would hear that you will get to this terminology. You need to know this protocol, right? Anyway, CPU is talking to the UART through that connection. So if you execute LDR, memory access instruction, memory read or memory store, STR instruction, then you are touching those FIFO. Those are memory mapped. If you look at registers, look at this. TX-RX54, right? That is mapped at that location, offset 30 from UART1, right? That is a base location. So if I write the location of these two, 0xe30, then 1030, right? 1000, that is base location, and offset, right? How far this TX-RX54 is 30, right? So that is 30 plus 30. Okay, so offset 30, right? So by using that address, you can write something into TX54 and read from, right? If you use STR instruction, then you are touching this, okay, targeting that location. If you use LDR, memory read instruction, then you are touching this. The little bit strange thing is that these two FIFO, this one is 64 byte, okay, 64 byte each, 64 byte each, right? So little strange thing is TX-RX54, these two are mapped at same location. A little bit strange, right? How come? How come these two buffers are mapped at the same location? Then how do you distinguish? How do you distinguish these two? Simple answer is these two instructions, right? So if you execute memory write instruction, then your intention is you want to write to TX buffer because you want to send some message to your PC. Hello world, right? Hello world message. Hello H, then E, hello, something like that, right? So here you write H, then this UART will send bit by bit through that connection to the PC. So we'll talk in detail, okay? And if you execute LDR instruction targeting same location, then you are not accessing. You are not accessing this. You are accessing, this RX54. You are reading from. So the secret is this connection. If you execute, one of these two instructions, that information is delivered through that connection. What information? Address, right? Which address? That address. E301030. Then data, right? Data. So in case of hello world message, hello world, then character by character, you are first writing H to TX buffer. So H, what is H? 48 in hex. Okay, that information is delivered to UART. And these two are not enough, right? Address and data. Some you need to have some control information. What do you mean by control? What kind of transaction you are performing? A read transaction, store, write transaction, or some other transaction. Right? Those transaction information is encoded in the control signal. So from UART point of view, by looking at this control signal, UART can tell, okay, you want to access this TX54 or RX54. So the thing is, even though you are using same base location, TX54 this location, RX54 this location, same location, hardware can distinguish one of these two. How? By looking at this control signal. Okay, so it is very related to hardware design. So you have to think a little bit more about how that access is access is actually designed in hardware. Okay? So from you think about that, you are taking address information because there are many registers, right? There are these many registers. You need to figure out which one you are targeting, right? Address. And data is obvious, right? Data. And one more is control signal, right? The read transaction, write transaction, and so on. So from hardware point of view, hardware should look at these control signals and determine the register, right? Determine the register to read or write, right? Okay, so that is probably confusing information. TX RX54 is mapped at same location. With Juan's case TX5 memory with only 32. Juan, are you talking about this? 32-bit. So meaning that it is okay. So it is 54, right? A little bit strange, right? So the thing is this actually it is 8-bit. It's supposed to be 8-bit because each one 64 byte. So it is talking about it's individual. You are programming individual byte with strp or ldrp. You are supposed to use byte access instruction because you are programming this specific byte. Okay, but okay, so probably better example. Do I have some better example here? So it is talking about register width. Okay, so the thing is, for example, control register, right? Control register 32-bit width. Control register, right? That is a bit 0 to bit 31. But if you look at this, actually you are supposed to use how many? 0 to 8. So 9-bit only. And the other bits are reserved. You're not supposed to do anything with that, right? And what else? Probably baud rate generation register. Okay. Also 32-bit width, 32-bit. But actually you are supposed to access only 16-bit. Okay. here, CD. Something like that, right, Juan? So here, data register. TXRX54, it says 32-bit register width, right? This width, this one. But it is, actually 1 byte. It is not. It is not actually 32-bit, 4 byte. It is not. But that means when you access TXRX54, you can use STR or LDR instruction, because it is what? It is word access instruction, 32-bit data access instruction. So it's okay. It's okay to use word access instruction, because physically you have that 4 byte, but actually you are supposed to use this LS byte. A little bit confusing, right, Juan? Is it okay, or then if yes? So thing is this: let's say STR, STRH, STRP, right? And targeting same location, right? Their location, this location, this one, R1, 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 and R2. Let's say R2, R2. Okay. So let's say R2 contains some value like 0, 2, 3, 4, 5, 6, 7, 8. Then I think that information, only that information will be written to this byte. Even nevertheless, which one do you want to use? It doesn't matter, right? Only that information, okay, will be written to here. I think probably you can test. I think that UART will work that way. So a little bit confusing. Okay. Okay. I see what you're saying. Okay. So that is also good. Good question. You say 64 byte, right? And according to that memory map, you are supposed to use only that memory location. Okay. So very strange. 64 byte. Then it is supposed to be probably starting from that location. 64 byte is what? To the power of 6. So 6, right? 6 bit. So from that location, to what? In binary, 3 is what? 1, 3 0 is 0 0 1 0. 1 1, sorry. 4 zeros. Okay, so 6 bit, meaning this. Okay, so from here plus 1 1 1. Okay, so plus 1 that location. Okay, so that location plus, right? This one plus this one plus 6 bit, right? That means plus what? Plus 1 1 1 1 1 1, right? The location plus this one plus the location. Okay, so let me use this. So 0. Let me to make it simple. Okay, let's assume the TXRX54 starts from the location. Okay, then the last location, because 64 byte, right? Last location would be E000. Then 6 bit, right? 1 0 3 F. To touch individual, right? To touch individual byte, right? It's supposed to be, right? There is 64 byte range. Right? All 6 bit, all last 6 bits are 1, then 64 byte, right? Okay, forget about this. 6 bit, right? 1 1 1 1 1 1. So 0 0 0 0. So from their location to the location. Okay, 0, all ones. So 0, okay, 0 and 3 F, right? 3 F. So that is 64 byte range. Okay, so if the memory map says, assume that memory map says, okay, TX buffer, RX5 buffer, start from their location and end location is this, then we are happy, right? Because using that 64 byte space, you can touch this specific byte and this byte and this byte and so on, each byte. Does it make sense? Hold on. Okay, so probably this one is more understandable, but the spec says, okay, so you are supposed to use only one location, right? That location. You are supposed to use only that location to access 64 byte. So very strange, right? What do you mean by that? Just one location? How to access this individual, byte? That is a question, right? Juan's question, right? So the thing is, you keep using. Okay? You keep using that location, 30. Okay, then secret is FIFO, first in, first out. First in, first out. You, for example, you write HELLO, targeting that location. Then hardware, what's happening in hardware? First H will be written here, then E written here, L, O, something like this. Okay, so it is going to, hardware will shift. The secret is you write here, then hardware FIFO, first in, first out, shift. Okay, so first H, you write H, then the status, right? H, then next E, then hardware will do shift, right? H, E. Then next time L, H, E, L. So that is happening in hardware. So you don't have to worry about that, memory, this memory map, 64 byte. They keep writing to the same location. Hardware will shift or push that data. Okay. So does it make sense? Okay. Yeah, a little bit, a little bit strange, sometimes confusing, right? Good question. Okay, so let me remove. So any question about this? We have zinc and UART, okay, TX54, TX54, or buffer, right? Buffer. So 64 byte. Okay, TX54, RX54, 64 byte each. Okay, you see. Okay, that is the one. Then, okay, that is the one. Okay, so use store byte or load byte instruction. store byte instruction to write the data you want to send to other party, other entity. Okay, and use LDR instruction to read from RX54. Probably PC is sending some message through that connection, RX connection, 1-bit connection, physical connection, right? 2 physical connection. Then that information will be stored in RX54. Okay, then you can just read. Okay, using program LDR instruction. Okay. Mic sounds going down for me. Is it okay for now? Okay, okay. Okay, then, okay, that is the block diagram, right? So we have CPU, then this part, that is a UART. So important, important hardware component, TX54, RX54. So if you store data to TX54, then this hardware component will read bit by bit. Okay, for example, okay, let's go, okay. So H, right, hello. H is 48 in hex, right? According to ASCII table. Okay, according to this ASCII table, big H, right? That is 40H in hex, okay, or 72 in decimal, right? 48 in hex. So if you write 48H, then H, then that information 48, 48 hex, right? In binary, what? 0, 1, 0, 0, 4, 1, 0, 0, 0 will be stored in TX54. Okay. Then hardware, right? Hardware, which hardware? The transmitter. Transmitter will take out bit by bit, right? Starting from this one is a D0, D0, data 0, data 1, data 2, data 7, right? So look at this, packet format, right? D0, D1, D2, D3 to D7, 8-bit data. Okay, so what happens is it is sending that hardware module is taking out each bit and sending through that connection like this. Okay, first start bit. So if I draw real detail, then start. Okay, status start. Okay, then D0 first. Okay, 0, right? 0. Okay, D0. This one is D0. Okay, then D1 is also 0. 0. D2 is also 0. D3, okay, 1. Okay, 1 like this. Okay, then 0. 0, 0, 1. Okay, and 0 like this. Then stop it. Stop. So that 1 and 0 will be transferred through that connection. Then PC. On PC side, it is it is sampling. PC is sampling internally, right? Internally sampling this data very fast, to take out each bit. Okay, I know it is start bit. Okay, D0, now I know D0 is 0, and D1 is 0, D2 is 0, and D3 is 1, and so on. So that is happening inside the PC. Okay, and get 48. It is trying to extract bit by bit using that fast clock. Right? This one, PC side. Okay, using okay, this one, right? So both sample, right? So on PC side, the similar clock is used to sample. Look at this, start bit, right? And it is running very fast, this clock, right? And so you can take out, okay, this is a start bit and D0. Okay, or same thing goes to D0 and D1 and so on. Okay. Okay, then let's talk about the code. Okay, so this is the one we executed last time, right? Okay, then probably in the first one first. This one seems very strange, right? UART init. It is not, function, right? If it is function, like UART hello, UART hello, that is function. That is why you use BL, branch and link instruction. But it is not using, you are not using any instruction, right? Just UART init. So where is it defined? Here, init. Check out this. So we use macro. So that is defined as a macro, okay, not function. So what does that mean? That means if you compile it, let me open this debug, please. Okay, main. Okay, look at this. Init, right? That macro. Okay, so it is not calling function. It is that actual the code inside the macro. Okay, got pasted here. Just pasted it, right? It is not calling that function. Then macro is whole macro, whole, the instruction, whole program inside the macro got, pasted. Okay, here. So that is the one. Okay. Then this one is calling, you are calling function, right? Calling function, executing, then you return, right? So branch and link. So there is in case of UART hello, there is only one copy. Only one copy. You are calling that function, then you return. But when it comes to macro, you paste. So if you add, for example, so for test, if you add one more init, okay, for test, okay, then what happens? There are two copies, right? Two init copies pasted, right? It is pasted two times, right? So let me. Okay, first you are in it, right? Then second, okay, location. Look at this. 5E8, 5EC. So two copies, pasted. Every time you use that macro. Okay. Let me remove one. Okay, so that is initialization. In the initialization, we do what? We set operating condition. Before you use UART, you have to set operating condition, the speed, how fast you want to transfer data at, right? We want to data transfer at 115200 bits per second. Okay, there should be agreement between these two entities. Okay, UART. Okay, I'm going to send the data at this rate. So PC, okay, I'm going to take data at this rate. I'm expecting, same rate. There should be agreement. Otherwise, no communication, right? Right. So you are, using Korean. Campton is using English. Then no communication. You are supposed to use same language to communicate, right? Same, same language, right? These two guys should speak same language for communication, right? That is too obvious, right? So that is data rate, data speed, how fast you want to transfer data, and also packet format. Okay, how do you want to transfer data? Which packet do you want to use? Okay, I want to send 1 byte at a time, something like that is a packet format, right? I want to send 1 byte inside 1 packet, or 7-bit or 6-bit, depending on your configuration. Okay, so you have to make agreement. These two guys should use same protocol. Otherwise, nothing will happen. Something will happen, but this guy will, receive junk information. Okay, junk information. I can show you. Okay, so for example, okay, let me show you now, probably. So here, let me turn on the board. Then say, okay, download it. Okay, first open this Teratom. Okay, so now we set a baud rate to what? Set baud rate to 1152. So if you check out this setup serial port, then you are using, we set, okay, PC side, okay, I'm going to use 1152, same, right? JBoard side, JBoard is using 1152, same speed, right? So we set CD using this baud rate register, and what? Okay, baud rate divider register. We set the speed to close to, not exact that number, not exact this number, 1152, but close to that number. So there would be some problem every once in a while, right? There is error rate. Okay, so 1152. Okay, same. So 8-bit format, 8-bit data. Okay, parity. I'm not using parity, and so on. So now these two guys, right, JBoard and PC, are using same protocol. So let me download it. Then hello. Okay, this one debug. Okay, let me just execute. Okay, F8. Okay, F8. Hello world, right? So I set breakpoint here. That is why it stops. It stops here. Let me remove the breakpoint. Okay, then F8. Hello world, right? Keep printing out. But what if I change? Okay, let me stop it. And what if I change this baud rate to some other? Okay, I'm expecting this one, for example, 9600. Then the thing is, PC is using different, PC is expecting different, speed. Okay, then probably execute it. F8. Okay, let me do it again. So what is something TX54? Why it stops? F8. Okay, some junk information. Look at this. Right? So PC is receiving some junk information because these two guys are using different protocol. Okay, so that is too obvious, right? So let me change back to, I'm not sure it is working, 1152. Now, okay, some sync problem. Okay, you have to do it again. Some sync problem. Okay, let me download it again. Okay, hello world. Okay, okay. Okay, so let me execute here, then hello world, right? Normal message. Okay, then now let's analyze this code line by line, okay, instruction by instruction, because you are new to UART. Okay, stop it. Stop. Disconnect, probably. Okay, then better to show you. that register information. Because we are dealing with, registers. This IO is providing. Okay, that is part of device driver programming. Device driver, right? Device driver, right? Device driver. So hardware is there. Okay, hardware alone cannot do anything. You have to use that hardware using software. Software is controlling this UART, IO devices, right? That is called a device driver. Right? You are driving this device, right? Using software, device driver, right? So if you are interested in kernel development or system development, you have to dealing with these registers. IO is provided. Okay, so probably put this one side by side. Okay, so here let me make it small and important. Okay, so side by side. Okay, so do it again. How is it multiplication if there are more bits in symbol? How does it? Camden, multiplication? What do you mean by that? If there are more bits in symbol? How does the bit rate go up? Can you elaborate more? I cannot get. Oh, okay, previous slide. Okay. This one? P. This one? Okay, so this slide is talking about, difference between bit rate and baud rate. Probably you can ignore that, difference, because when people, use these two terminologies very mixed way. So bit rate, okay. Bit rate, right? Bit rate, and baud rate. So again, people use these two terminologies in a very mixed way. Sometimes you use bit rate, sometimes you baud rate, no difference, right? But there is a clear difference. So what is the difference? So taking this one as an example, 1152, you are sending, right, bits per second, right? That is bit rate actually, bit, right? You are sending these many bits every second, bit rate, right? Then what is baud rate? What is baud rate? How many symbols, how many meaningful data you are sending. That is a, how many, in other words, how many symbols you are sending every second. So taking this one as an example, hello world, right? Hello, for example. Each one is symbol H. Okay, it has some meaning. H, right? E, L, L, O. Each one is a symbol. You can think of it as a symbol, right? So if if you clearly distinguish these two, then you are sending data at this rate. Okay, 1152 bits per second. That is, bit rate. And in this case, each symbol is composed of 8-bit, right? H in ASCII code, 40H. So if you want to clearly distinguish these two, then that is, in this case, that is converted to 1152 divided 8 baud rate. Divided 8. How many characters? In other words, how many characters you can send? So let me 1152 divided by 8. So that means you can send 14,400 symbols for rate. These many symbols, these many characters every second. That is the difference between these two. Okay, but if you think, okay, I'm going to consider each bit as a symbol. Okay? Instead, this one, okay, each bit has a meaning. Okay, this one, I'm going to think of each bit as a symbol, one symbol. Then these two are equal. Bit rate, baud rate are equal because this is going to be 1, not 8, right? Okay, but people, many times, people don't distinguish these two. Just to use BPS, baud rate. This just say baud rate. Okay, baud rate or bit rate. Right? I think this one is more widely used. Baud rate. Okay. Okay, good question. Okay, any other questions? More bits per symbol would make bit rate go up instead of go down. But so according to the UART, you are supposed to set this transfer rate, right? That is actually bit rate, BPS, right? Bit rate, BPS, right? Then baud rate will be going down, right? If you think each one is a symbol. If you think of it, each character is a symbol divided by 8 in this case. Right? So bit rate, BPS is fixed. Then baud rate will be smaller because you have to do division, right? So probably this one is misleading, right? So symbol, in this case, B. Okay, n is what number of bits per symbol? Your 8-bit, right? 8-bit. Right? How many symbols? S. How many symbols you can transfer? So there is so left side B, right? S multiplied by n. This one there is bit rate. This one symbol baud rate. Baud rate. This one is bit rate, baud rate. Then n is how many bit you are using per each symbol, right? So how many symbols? Number of symbols. How many symbols? How many symbols you transfer every second? Then how many bits? How many bits you use for each symbol? Right? So symbol canceled out. You get bits per second. Right? Okay, you think about that. Okay, probably I have to show you this register. Which register? Channel status register. Okay, this one. Okay. So then let's follow this code instruction by instruction. Okay. So initialization, probably you can check this out, right? So that is the configuration, operating condition set. So we can skip that part probably. Okay. Then okay, F5. Okay, here UART hello, right? Check out registers. Okay, F5. making function call. Okay, so you execute that line, load instruction. You are loading what? You are loading the location of the first character, this symbol or a label. Okay, so if you look at the ELF, the compiled binary, then you can find the symbol table, the string symbol table, right? String. String is located at 120A14, right? That is symbol table. UART hello, that symbol is located at this location. TX loop and so on, right? Symbol table. Compiler is generating symbol table to let you know the location of the symbol. Okay, string is located here and so on. Okay. So check out this string. Okay, find. So where is hello? Hello. Okay, check. Too many hello. Okay, too many hello. I don't know. Okay, so hello, supposed to be somewhere, right? So that actual the data age. I want to show you 48, that number. Okay. So let me try one more time. String. Where's the string string? Okay, 100. Search with this. Search with that location. Probably. Okay. Somewhere, right? I don't know. Okay. Okay. Then again, this code stores the location of the first character into R1 register. Okay, that code. Okay, let me execute F5. Okay, 5. So R1 A14 according to the symbol table, right? So then you can do this probably. Remove this. Remove memory monitor. Okay, so 100A14, right? Look at this, 48. 48 is hex, H, right? 48, big H, right? 48 in hex. Then E, small e, HE, small e, very small e. Here, 65 in hex. That is why you have 65 in hex. Here, L, small l, 6C, 6C, 2L, right? LL, O, okay, small o, 6F, here, 6F. So HELLO, okay, and space. What is a space? Space, according to this, 20 probably, 20, right? 20, 20, where is 20 here? Okay, space, right? 20 space, 20. Okay, so you have that HEL, that string stored from the location, from this location. Okay, so now status register, right? Status register is defined here in the code. Okay, status register not start from, located at this base plus 2C, 2C. Okay, E 3 zeros 1 0 2C. Okay. Let's execute this. Okay. R1, right? R0, sorry, R0, 102C. Then TX54, okay. Reading from status register, channel status R0, right? So reading that register. Okay, reading that register and storing to R2. So F5, R2 is what? A0, meaning 1010, right? A 1010, last 4 bit. So here, this one is 1. Look at this, 3210 bit, right? So important information, 1010, okay, 1010, A, okay? R0 means read only, read only. You're not supposed to write, right? You are supposed to only read because it is status register, right? Hardware is recording the status of UART, right? So you are not supposed to write, update, right? Hardware is recording the status. So your job, just read that information and figure out what's going on. Okay. So 1010 meaning what? TX54. One means TX54 is empty. 54, right? This 54. TX54, right? TX54 is empty. So here, TX54, right? This 54 is empty, right? Empty. Nothing is here. So please, you can write, you can update. So now, so how do you? So 1010, how do you check that TX54 is empty? Look at this, 8. You are doing AND operation with 8. Why do you do AND operation with 8? To extract, to take out that bit. 8 is what? 1 3 zeros. 1 3 zeros. That means you want to take out that bit, TX empty. If buffer is empty, I want to write something. Okay, if your buffer is empty, right? You want to send some data. Okay, so compare, right? If R2, AND operation output, right? If empty, TX empty is equal to 1. These two are equal. Compare, right? Compare. Okay, let me do this. F5 here. So R2 is 8, right? R2 is 8. So R2, 8 is equal to 8. Compare, right? So these two are equal. That means what? 54 is empty, right? Then like this. CPSR, right? Compare instruction is updating CPSR register. Okay, these two are equal. So 0 flag and carry flag will be set. But we are not using carry flag in this case. We want to check only 0 flag, right? These two are equal. Look at this. Okay, let me check. So no change. Already 1 1. So probably no change. Okay, no change in flags. Okay, then TX5 loop, right? Not equal, then you have to go back. Not equal means what? TX54 is not empty. So I want to wait. I want to wait until data is sent out to the PC because there is a data. Okay. In this code, we want to use even though. So one probably important to make this example simple. Even though there are 64 byte, I just want to use just 1 byte. Okay. I don't want to keep pushing. I don't want to keep pushing data. Just want to use just 1 byte. So if everything is empty, FIFO is empty, nothing, then I want to write byte H. Okay. Then I'm going to wait until H is sent out. Then TX is empty, then next character E. Then I'm going to wait until E is sent out completely. Then, then next character L. So very simple, example. I don't want to use your 64 byte whole, right? I can do H, E, keep, writing. but I don't want to do that. Okay, that's the example code. Probably that is simple, right? Simple code. Again, I just want to use 1 byte in 64 byte FIFO, and I want to wait until this TX54 is empty. TX54 sent out the data. Okay, empty, then next character. Sent out, okay, empty, next character. Okay, like this. So now look at this. TX54 is empty now, right? TX54 is empty, so you fall through, right? You don't go back. You don't go back, you fall through, right? F5, oops. Okay, F5, okay. Then what? You are reading from R1 string, right? Location of string. You are reading from the location, so H. First character will be stored in R3. Okay, so after reading first character, R1 register will be updated. +1, right? Post indexed, remember? Okay, memory access instructions. So R1, okay, look at this. R1 A14, A14, and it will be A15, A15, 1 plus 1, right? After executing this code. So R3 will have 48 first character, and R1 will be incremented by 1. Okay, let me execute. So remember A15, right? It'll be A14 now, it'll be 5. Like this, A15 now. Okay, and R3 register 48. That is H, big H in ASCII code, right? Okay, then look at this one. This location, this TX54 location. Okay, so you want to write that first H to TX54. Okay, so F5, R4. Okay, look at this. 1030, right? 1030. That is the location of TX54. Right? 1030. Okay. Then this one. Okay. Store instruction. Store instruction is actually writing first character to TX54. Okay. So H2 to TX54. So F. Okay. Then you will see some message. Okay. So already here F5. Okay. H. So here H. So first character. Okay. So once you write first character, then UART hardware will take bit by bit and send out to PC. Okay, to PC. Okay. So that is why, as you know, you write this data to TX54 almost immediately. We as a human cannot, recognize that fast speed, right? It is using 1152 1152 hertz to transfer data. Hertz. 1152 hertz, right? To send the data. That is the speed, right? So human, right? Human cannot, feel that speed. Very fast, right? Very fast. And then, what is that? R3. So data, right? You read you read first data and place it into R3. And the data is stored in R4. Then next instruction, data, is it equal to 00? So I'm trying to check the exit condition, hello world message, and at the end you have null. Okay, so the character you send is null, then I want to finish. Okay, that is the one, right? If R3 is equal to 00, then I want to exit. Not equal, then you go back. Not equal, you go back. Equal, 0, 0, then you fall through. Meaning, okay, I'm done. I finished sending whole message. This whole message. Okay. So F5. For now, it is not equal to 0, 0. Okay, so 0 flag is 0, 0. Okay. So you go back. You keep doing this. Look at this. All right. So now here, if I press F5, then here E will appear. Okay. 5 like this. E. Okay. Then here, then store byte, then H will appear here. H, right? L, and so on. Okay. Any question? Can we see in memory view? Hojun, which one? See what? String. Yes, that is the one, right? Even though it displays in a hex number, right? That is the data. H, E, this one, first one, H, E, L, L, O. That is memory view, right? Memory view is showing only data, right? Not, ASCII translated, human readable, symbol, right? It is showing only the raw data, raw, ones and zeros, memory, right? Null, there is no null in hello world string. There is no null, right? Space is not null, right? Space is also space is one code, right? In ASCII, space is this one null. 0, 0 is null, right? 0, 0. So if you you transfer everything and hit this null, then you are done, right? I finished sending whole message. So I want to finish. You want to fall through. Okay, branch, then you don't want to go back. Okay, fall through. If we want to use more than 1 byte in the buffer, do we have to increment the address? No. Okay, Haechang, no, right? That's what Juan asked, right? Before, right? You don't have to. So you just keep. So, that is, okay, I spent some time with Haechang, right? So these two, E000130, you only use this one location to access both. That is one strange thing. And the other strange thing is, okay, that is 64 byte. Then just to use one memory location doesn't make sense, right? So I spent 10 minutes, right? What's Haechang, right? At the beginning. Probably you can play back. Okay, I'm going to post it on YouTube. Okay. Okay, any other question about this? Okay, one more thing for you guys to do the assignment. Let's go back to here. So fourth assignment, okay. Okay, here, let's take a look at this. Hojun, can you please read this one?
To the assignment number 3, the only difference is the input source. Instead of the switches, take input from your computer via UART. The UART terminal on your PC should display the following menu for taking keyboard input. Show the same menu after the selection for the next selection. You are free to use C, assembly, or both.
Okay, thanks. So this assignment is asking you to take input from PC. Okay, instead of taking input from switch, right, JBoard, right? JBoard and switch input. Okay, don't take input from switch. Take input from PC, your PC, right? So you are supposed to display this menu. Okay, then select, right? Using keyboard. Hold on. Okay. Okay, using keyboard, take input, right? Press 1, then duration is 100 millisecond, 200 millisecond, and so on. So how to take input from PC? There's a question using keyboard, right? The thing is, teratom, right? You have teratom. Using the teratom, you can send some character, that 1, 2, 3, 4 character to the JetBoard, right? So you have teratom. Then display the menu, that menu, okay, LED on duration, 1, 2, something. Then on teratom, okay, you use keyboard to to write something. Then that information will be we have TX connection, then RX connection, 2 connections, right? So last example, you send message, hello world message, to PC through that TX connection, through that connection. Okay, so now we want to use both, right? So that connection too. So you are sending this message, one selection, to the JetBoard. Then that will be stored in RX54, like the one. Whatever the actual ASCII code is. What is ASCII code? ASCII table. So one is what? One is 31 in hex. Or one is 31. So 31 will be stored here. Actually, 31 in hex stored here. So you read. So you read that information, then turn on LED. Okay. So that's what I'm asking. Then the question is, how do you take input? Right. So there is an example code. Example code. Here, UART echo. Okay, there is one echo. Okay, so let me execute it. Okay, here. Okay, close it. So I already created project, but let me do it again for your reference. New application project. Okay, I downloaded. Okay, I downloaded where? Let me show you the place where. So last night I downloaded. Okay, the UART echo and unzipped it here. So you have 3 files here. Okay. So we want to import. We want to import these 3 files into our project. So file, new, application, next. Okay, hardware platform. We are using same hardware platform. It's CSD platform we created before in the first lab assignment. Next. Okay, application project name, anything is okay, right? Test about that. Test. Okay, next. Default is open. Okay, I can create hello world program for you. Okay, finish. Then here in source. So we don't need actually hello world program, right? Just remove it and import the 3 files you downloaded. How to import? Simple. Source, new, not new, new, import. Okay, here. Source, import sources. Okay. Then select the folder. Okay, this folder. UART echo. Okay, download UART echo. Same, right? UART echo. Okay. Then select folder. Then, okay. Select this one, then these three files will be selected. These three. So finish. Okay. So echo here. We have a code main. This label is used in this echo. So hello world. You can either rename this main to other or just remove it, right? We don't need this actually. So remove it, right? Okay. Now compile it. Compile the project. Control B. Terraform software is set protocol for communication. Yes, yes, you are right. Terraform is software running on PC side, right? Running on PC side, using the software, the providing that UART communication protocol. So very useful. Not only UART communication, but TCP. I think look at this serial. Some SSH also. You can do SSH, TCP, several capabilities. So one of them is serial the UART communication using the port. Yes. Okay, it compiles okay. Then check out. Okay, check out this hello echo. Very simple code here. Same initialization. Okay, we used before. Then you are still checking this status register. Okay, doing what? So it is checking now, not TX. It is not accessing this TX54, but accessing RX54. How? Using LDR instruction. You are using LDR instruction. Okay, so R0 is still that location. TX54, TXRX54 location. Okay, so okay, and then R1 is status register. From status register, you are reading R2, then checking what? Look at this. Okay, time is running out, so I want to a little bit move fast. Okay, so R1 status register. You read this information to R2. Then now we want to check what? RX, right? RX empty, I think, because you are doing one bit shift left, one, doing end operation. That means you want to take out that bit, RX empty, receive FIFO empty or not. If it's not empty, look at this, compare. If it is 1, that means what? RX is empty. Okay, RX is empty. So no data is received. Data has not been received. So that bit is 0. That bit is 0 means then something, I got something. Okay, this RX empty is 0. RX 54 is not empty. 54 is not empty, right? Something is inside empty. Okay, PC sent out something. I got something. Then equal means empty. A little bit confused, right? Empty. These two are equal. R2 is equal to 10. Then that means it is equal. RX54 is empty. So you have to keep checking. RX54. Okay. So you got something, then you fall through. Okay, I got something. Okay. So I'm going to read from 54. Okay, that is confusing part. I'm going to read from 54. Okay, you got character. So using LDR, we are using LDR. Okay, LDR or LDRP is okay. LDR, you are reading something, and next instruction is STR, store. You are writing the same data to FIFO. Okay, next instruction, STR. That means what? You want to send out the data you received to PC. Okay, send out the data to PC. Why? Because I want to display this character you typed. So you type you use keyboard and type 1, then nothing will happen. Nothing will be displayed. Okay. Then for human, it is very strange. You typed something, it doesn't say anything. Teratom doesn't say anything. Then you don't have any clue what's going on, right? You are confusing. So that is why using that echo program, I want to send out the data you received back to the Teratom. So in this way, you can display the character you typed. Okay. So here, you type anything, you type something, nothing will happen, right? Here, nothing will happen, right? So using that echo program, I want to echo back the character you typed. So let me quickly run this program. Okay, not hello world. Test. Okay, I have to do it again. It's not this hello world program, right? Okay, do it again. Close. So test we created the one. We close this one. Okay, echo. Okay, this one. So click on this, then debug and debug configuration. We create new session for the project we just created, application. Okay, test. Okay, so debug. Okay, then let it go. Okay, next time I can analyze the code instruction by instruction, but we ran out of time already. So let me just let it go, F8. Okay, then Teratom. Okay, you type something. Okay, this is working fine. Okay, like this. Okay, you type something, then you echo back. This UART will echo back and display the message you just typed. So in this way, you can take input, right? You can take input, then you can do the assignment, I think. Okay, any question before closing up? Okay, midterm, what do you think? Midterm exam, good question. Probably, how about 28th? 28th of 28th of this month. 28th. Is it okay? 28th. Okay, let's fix. Okay, 28th midterm exam. April 28th. Okay, midterm exam. Okay. Okay. So that is in class. In class exam, you have to come to the classroom for the exam. Okay, no online exam, right? You have to come to the classroom. So probably after midterm exam, we have to switch to offline class. I think we have to switch to offline. Okay. No, I don't think, Camden. We have to switch to offline. We have together in the classroom. Okay, after midterm, then see each other. Then we can get more interaction, I guess. Okay, that would be better, I think. Okay. That's it, I guess, for today. I'll see you next time. Okay, bye. Okay. Thanks.